How you doing?
I'm good. How about you?
Good. So are you done with
Hi.
baseball for a while?
Oh, we're not. We have a couple more weeks left. We have practice Tuesday, Wednesday, and Thursday this week. A couple games this weekend, and
Huh?
then a few more practices, and then we got Arizona to end
I,
the season.
I
So.
figured you were all done because your dad called me this weekend
Hmm.
and wanted to lock up the 5 o'clock spot on Monday and Wednesday for the rest of the year.
Really? No?
So I was a little curious because I
Yeah.
I figured that meant your baseball must be all done. But I did
That is.
kind of remember you telling me that it wasn't done. So
Yeah.
maybe you need to talk to him and figure out what to do. Uh,
Yeah,
only
for sure.
because I'm getting really full.
Okay.
It's like today I was booked solid from 3 until 9, and
Wow.
and then I had some cancellations, and that's why this 7:30 spot opened up. But
Gotcha.
I can't
Okay.
always guarantee that your 5 o'clock is going to have a later spot open up. You know what I'm saying?
Oh, for sure.
Uh,
Yeah, no worries.
So I can probably offer you either spot on a permanent basis if you know which one you want.
Okay. Cool.
Okay. Uh,
Yeah.
all right. Let's look at some of these. You want to start at 16?
Yeah, we could start there.
Okay.
Cool.
What's first step?
Well, first you're gonna find the greatest common factor, right?
Good. That's always the first step. Yeah.
Cool.
What's the greatest common factor? And include both numbers and variables.
Okay, we could do 5h to the, yeah, just 5h.
Actually, you can do 5h squared.
Okay.
See why?
Um,
In other words, that right there is the smallest power of h.
okay.
So I can definitely divide every term by h squared. Okay, I
Okay.
can divide that by h squared. In fact, I can divide by 5h squared. I can divide that term by 5h squared, and I can divide this term by 5h squared. That's what
Cool.
the greatest common factor has to be able to do. Is it has
Okay.
to be able to divide every term by the greatest common factor and come out with integers,
Okay.
not fractions. In other words, I could divide every term by 10, but I'd come up with a half here, and I don't want that.
No.
So what's left here after I divide everything by 5h squared?
So it would be 6h squared. Right. Okay, yeah. And then minus 5h. Um, and then minus h, just minus h.
No, what's that term divided by 5h squared?
Minus 1h.
Just one.
Is it just one? Okay.
Anything divided by itself is one. It
Okay.
doesn't matter how complicated it is. I could have a super complicated numerator, and as long as my denominator is the same thing, then the quotient is one. Hold on one moment.
Okay, yeah, no worries.
Close my door so I'll shut out the barking a little bit.
No worries.
All of these programs most likely, or all of these problems most likely are going to come down to where after you've taken the greatest common factor out, you're left with a quadratic
Okay.
because they haven't taught you how to deal with cubics.
No.
So know that when you're looking for a greatest common factor, you better have a quadratic left.
Okay.
Otherwise, there's big problems.
Mm-hmm.
Okay. Now we
Okay.
have to figure out how to factor that quadratic.
Okay.
This is a little bit tricky because there are multiple factors of 6. In other words, I could use 3h times 2h, or I could use 6h times h.
Mm-hmm.
Which one do I tell you to always start with?
Uh,
The two factors that are closest together.
yeah.
Which two are that?
6h squared and 5h.
No.
Wait, what are you talking about?
Okay, we're factoring the number 6.
Okay, yeah.
And
Oh, yeah, that's what you mean. Yeah, it'd be 6 and 1 to get minus
no,
5.
which factors are closest together?
3 and 2.
Yeah, that's always where you want to begin.
Okay.
Well, that's not going to be the correct answer here, but 90% of the time it is the correct answer.
Okay.
So it's a trial and error process, Dylan. So you always want to start where you have most likelihood of success. And
Mm-hmm.
the signs have to be plus minus or minus plus. And the only factors of 1 are 1 and 1.
Yeah.
Now, you'll notice that that does not produce minus 5h in the middle.
No.
No combination of 1s will produce minus 5h in the middle. I could try the negative 1 over here and the positive 1 there. I'm not getting to minus 5h. So
Mm-hmm.
what that tells me is, I got the wrong initial factoring. This is
Okay.
one of the rare problems where the best start is the two factors that are furthest away, 6 and 1.
Mm-hmm.
Now, if I put a minus 1 there and a plus 1 there, notice my inside is plus h, my outside is minus 6h. That gives me minus 5h in the middle, which is correct. That means this is the correct way to factor it.
Okay.
And it always comes down to whether you produce the right middle term or not.
Okay. Trial and error.
And that little double smiley face is absolutely vital. In other words, what we're dealing with here is a quadratic that's got a number greater than 1 right there,
Yeah.
6. That
Mm-hmm.
automatically makes it harder, okay?
Okay.
Because it takes away a lot of those real simple rules that I taught you about quadratics. You know,
Mm-hmm.
there's no such thing anymore as factors of the constant that add to the coefficient of the middle term. Those
Mm-hmm.
rules you can throw right out the window. You
Okay.
just have to kind of do a trial and error method.
Okay.
And you have to do trial and error on this coefficient too. Notice that I started out with 3 and 2, and that didn't work.
Mm-hmm.
But I didn't have any choices on the 1. You can only factor 1 as 1 times 1.
Mm-hmm.
So I really only had two different things to try, and that was a 3 and a 2 and a 6 and a 1.
Okay.
The first term. Okay.
Okay.
So that's our final answer. That's that expression fully factored.
Okay.
Okay. Now
Cool.
let's look at the next one here. 75
Okay.
h to the fourth. Figure out the largest number and the largest variable that will factor out of this.
Yeah. Um. Does.
It's a toughie. This is where it really, really helps if you know your multiplication and division. In other words, there's no calculator that's really going to help you here.
Right.
Figure out the largest number that divides into 75, 60, and 12. Okay?
Would 4?
Let's start with that. Well, 4 certainly goes into 12, and it goes into 60.
I don't think it goes into 75 though.
Oh, no. Multiples of 4 are always even.
Right.
No way 4 can divide into an odd number.
No. Would 3 be?
Well, so let's look at over here. Yeah, 3
Yeah.
goes into this, 3 goes into that, 3 goes into that.
Yeah.
And there's not that many factors of 12. 6, but 6 doesn't go into 75. So
No.
I think 3 is the largest number. What's the
Yeah.
largest letter that we
Um,
can
we could do
factor out?
3h.
3h squared.
Yeah, is the score.
Well, do you see why? I'm bothered by the fact that we did one just exactly like this just now.
Yeah, I'm just kind of confused on like
Okay,
the
here's the rule.
exponent. Yeah.
Here's the rule for greatest common factor.
Mhm.
It is the largest thing that divides into all three terms
Okay. Evenly.
evenly. Well, notice I can divide that term by h squared. Let's look at just the variables.
Okay.
I can divide that by h squared. What I
Mhm.
cannot do is divide each one of them by h cubed. Because if
No.
I divide h squared by h cubed, I get an h to the minus 1. That's not considered a whole number.
That makes sense. Okay.
Okay,
I
that's
think
the
I get it.
secret maybe. Yeah.
Yeah.
You
I think
always
that's what my brain.
remember that, well, the real secret is that if you have variables to a bunch of different degrees, the greatest common factor is going to be the smallest one, always.
Mhm.
In other words,
Yeah.
if that was like that, let's say that was my function.
Mhm.
I could only take an h out. I could take a 3h out, but that's it.
Okay.
I wouldn't be able to take an h squared because h squared does not divide into that properly.
No.
So
No.
if I have that, now I can take out a 3h squared. What do I have left over? Because you got to
Okay.
have both parts.
All right. So
If you
75
have
divided.
75 cents, how many quarters do you have in your pocket?
3.
Well, what's 75 divided by 3?
25.
Okay, 25 what?
So it'd be 25h squared, right?
Right. And before you even go to the next step,
Mhm.
multiply this. Somehow I lost my pencil.
Oh, you're
Multiply.
right.
Well, no, I'm not actually, because I need a pencil to be able to draw. Man. Okay, this happened the other day. I'm going to have to unplug it and redo it here.
Okay.
Just let me test it 1 minute here. Let me see if I can get it to work by just reopening it.
Yeah, no worries.
Doubt it. Yesterday this happened and I had to, yeah. So I got to close it. I got to unplug my tablet and then plug it back in and reopen it.
Oh, okay.
Oh, yeah. Okay, good. Huh. And it didn't erase what I had. Well,
Sweet.
one nice thing about this particular notebook program is that it, you're,
Saves your work, right?
well, you're always on one continuous scroll. I haven't quite figured out how to separate documents. I don't think I can. This
No.
synchronization that it does up here, I'm not sure what it's syncing with, but it leaves me with, I can just scroll forever. So
Yeah.
what's the second term?
It'd be plus 20h,
Good.
and then minus or plus 4.
Plus 4, exactly.
Cool.
Okay, now, one way to check whether or not you've taken the greatest common factor is to see, can I factor any other number out of here?
I don't think so. No.
Oh, I can't factor 4 into 25, and I certainly can't take 2 into 25. So
No.
that's it. So now we have to kind of guess. In other words, now the problem gets much harder.
Yeah, for
There are
sure.
multiple factors of 25, and there are multiple factors of 4.
Mm-hmm.
So we kind of have to guess at where to start. Where should we start? How do we divide up 25h squared?
Um, well, we could do just 25h and 1 and then 1 and 1h.
Always start with the two factors that are closest together. What
Okay.
factors of 25 are closer to one another than 25 and 1?
5 and 5.
Let's start there.
Cool.
Now,
So just
last
5h.
time I did this, the correct answer was 6 and 1, but I persist with the
Yeah.
thought that the average answer is going to be the two factors that are closest together.
Mm-hmm.
Now, what are both signs?
Plus or minus and then minus or
Oh,
plus.
no. You cannot produce a plus 4 with plus or minus.
So, oh yeah, my bad. So just be plus.
It'd be plus plus.
Yeah.
In other words, when I say both signs, I want you to
Oh, that's
give me
okay.
both signs, not just one of them.
Okay.
Both
Yeah, I thought you
signs at
just
the
meant one.
same time. Okay.
Okay.
Now, factors of 4. And
Yeah.
what do we got? We got 4 and 1, and we
And
got
2 and
2
2.
and 2. Which are you going to start with?
2 and 2.
Try 2 there, 2 there. Does that produce the correct middle term? In other words, that
Um,
always have to answer is, does that produce 20h in the middle?
it does.
It does.
Yeah.
Exactly. 10h there, 10h there, 20h, we're done. And notice that that is a necessary step for solving these.
Mm-hmm.
It's not just a checking mechanism. It's what we
Right.
have to do in order to solve them.
Right.
And that's our final answer.
Cool.
Okay.
Okay.
Pull up the other one here, the
Yeah.
other page. I'm wondering, let's see, we got 15 minutes.
Yeah.
Yeah, let's do another one of these.
Yeah.
I've always said you cannot get too much practice on factoring, and I still believe it.
Yeah.
And you're doing second degree factoring now.
Mm-hmm.
Their greatest common factor here.
There's not.
Okay, so it's just a straight quadratic.
Okay.
I'm expecting that we're going to be able to factor every one of these, that we're not going to have to use the quadratic formula,
Yeah.
but not necessarily. We'll find out. When I say I'm expecting it, that doesn't mean I know for sure, but so far they've given us hard quadratics that can be factored.
Yeah.
Tell me where to start.
Um, Let me think here. We could do, like our teacher taught us to do like, the chart. So like
Okay, I
E
don't
times
know
A
that.
times C. Is
That's the problem, Dylan. I don't know that method.
that the problem? Okay. Okay.
All right? So the
Okay.
only method I'm able to really teach you is
Mm-hmm.
my method.
Sure.
And hopefully you can separate them out. And
Mm-hmm.
it's never a bad thing to know multiple methods on how to solve something. In fact,
Right.
that's always a good thing. So if you can possibly learn my method and understand your teacher's method, we'll be better off, because I really can't help you with your teacher's method.
Yeah.
I've always hated the diamond method or the California method, whatever they call it. I really
Mm-hmm.
have. I find it confusing. My method to me is really simple, and I just can't hardly help myself from trying to teach it to a student.
Sure. Yeah, no
Okay?
worries.
So,
Okay.
well, at very worst, you're learning a second method. Okay?
Mm-hmm.
And
Yeah.
my method is just split that up. That's always the first step, always.
Mm-hmm.
regardless of whether you're dealing with an elementary quadratic or a second degree quadratic.
Okay.
So how do you split up 3k squared?
Just 3 and 1. So 3k in one of them, and then just k in the other.
K and k. There you go.
Yeah.
That's the starting spot, and that's the only starting spot. There's no other factors of 3.
No.
Okay. What are both signs? That's my next step.
They're going to be both positive or plus.
Okay. See, my method is actually very easy and very straightforward. And now, factors of 15. Here,
we got just 3 and 5, and then 15 and 1.
That's it. Those are the only two sets of factors. So we have to try various combinations here. And my method is definitely a trial and error method. Okay?
Right.
So we'll start with, where are we going to start?
We can start with the closest numbers together, so 3 and 5.
So 3 and 5.
Yeah.
Does that produce the proper middle term?
Let me see here. So 3k and then 15k. No.
Okay. Let's switch them. 5
let's switch
and 3. Does that produce the proper middle term?
It does not, no.
Come on, Dylan.
Wait, let me see.
5k plus 9k. What is 5k plus 9k?
14k. So yeah, that'll work.
That works. And that wasn't that hard to do.
No.
My method was really very, very simple. You split that up, and then you determine both signs, and then you look for factors of that number, and you just start trying them by trial and error.
Yeah.
Okay? Now, it's not like the California method doesn't use trial and error also. They do. Am I correct?
Yeah.
I mean, even if you're doing it like this, where you put numbers there and there and there and there, you're still doing trial and error.
It just takes longer to
well, it's
do
just a different trial and error. But you don't eliminate the trial and error aspect of this method by using the California method or anything.
Right.
The essence doesn't really change. No, let me see. Okay. What's the greatest common factor we're going to do on 19?
5.
Well, that's the number. What's the letter?
Oh, I'm sorry. Yes, it'd just be 5k.
Okay. And then you'll notice we're going to be left with a quadratic. Quadratic that you can factor.
Yeah.
Okay. So let's go to number 20, which is slightly different. 8k cubed minus 162k. What's the first step?
Let me see. So we need to find the greatest common factor, right?
Okay. What's the greatest number part? In other words, greatest common factor is usually, especially at this level, going to be a combination of numbers and letters. Now, you want the greatest common number between 8 and 162, and then you want the greatest letter between k to the third and k.
Okay.
So what's the greatest number? How is 162 divisible by 8?
No, it's not.
No.
164
not
is.
Close. Is 162 divisible? We can only try even numbers at this point. Because only even numbers will go into 8.
Right.
So the next lowest even number is 4. Is 162 divisible by 4?
I think so, yeah.
No?
162.
Notice that 4 goes into 16 exactly 4 times. So that remainder is going to be 2. And if you have
Yeah.
a remainder, then 4 doesn't divide into it. It
No.
divides into it, but not
Evenly.
evenly, exactly.
Okay.
Therefore, the greatest common number is got to be 2. That's
It has to be, yeah.
And I know
Mm-hmm.
2 because they're both even numbers, so I know at least 2 will go into them.
Mm-hmm.
The letter, the greatest letter that can come out.
Just K.
Okay, what's left over?
And then it would be, hold on. So it would be 4K to the second.
Okay, now before you do the second part, check the
Mm-hmm.
first part. Make sure that's right.
Um,
And you check it by multiplying these two things back together again.
yeah, you get 8K cubed.
Okay,
So,
good. That's the process you should use every single time. Don't
yeah.
wait until you've written the entire thing out.
Mm-hmm.
Do it piece by piece as you go. What's the next part?
It'd be minus 81.
Okay. Can I factor that quadratic?
Yeah, it's a perfect square. So you could just,
Difference of perfect squares.
yeah.
What are they?
So it'd be 2K parentheses. K minus 9 and then K plus 9.
Okay. Boy, you
Or 2K, yeah.
almost had me believing you knew how to do this. When you said
It's 2, it's,
you said 2K in the parentheses, that's the answer.
yeah.
Right there. And what you're
Yeah.
doing is taking the square root of that. It's not this 2K over here.
No.
It's the square root of that.
Right.
Minus the square root of that, which is?
Which is 9.
Okay, and what's the other half of it? You don't have to do any work for the other half.
And then it would just be K minus, or K plus 9.
2K plus 9.
Yeah.
In other words, whatever these terms are, they don't change when you do the other half of it. It's just the only thing that changes is the sign.
Okay.
Okay? So that's why I say you don't have to do any work to do the second half. You don't have to go back up here and refigure what the square root of that is and the square root of that.
Yeah.
Just take your answer and repeat it with the sign being different.
Mm-hmm.
And that's our 3 factors.
Okay.
All right, I've got 4 minutes, and I cannot even go a minute over. Let me see if I can find one that's a little different. Yeah, this one here.
Okay.
These are going to get tougher when they start having multiple letters in them.
Mm-hmm.
Is there a greatest common factor there? I take it back.
I don't think so, no.
They're a letter. It's common to every term.
K. No, A. Yeah.
A.
Just A. Yeah.
So A can come out.
Mm-hmm.
Okay?
Cool.
Now it's just a regular looking quadratic.
Yeah.
In fact, it's a first level quadratic. Help me do it.
So it'd be A and then in the parentheses it would be let's do K minus 9 and then K minus 2.
You're trying to do all 3 steps at once.
Just do one at a time.
Yeah, I appreciate that you got the right answer. But that method will not serve you well.
Okay.
Okay? What method will serve you well is if you do it 3 steps on 3 steps, not 1 step.
Okay.
For easy ones, you can do all 3 steps, but for harder ones, that just doesn't work. So there's step 1, split up your K's.
Okay.
There's step 2, determine both signs. They have to be the same because I have a plus 18 here, and they have to be negative because the middle term is negative.
Okay.
Now I can say factors of 18 that add to the number 11, and I can put 9 and 2 in there.
Cool.
Okay?
Okay.
So, you know, I mean, if you could do all three steps in your head on every single problem, I would say go for it. But
Right.
I know you can't. I can't. I don't know anybody that can. So
Yeah.
you want to memorize a method for doing quadratic factoring. That's the
Okay.
to memorize the method.
Right.
And it's actually not a complicated method. It's a fairly simple method. You just want to do it one step at a time. You don't want to try to figure out each linear factor all at once. It's just too hard
Oh,
to do it that
okay. Yeah.
way. All right. All right,
Cool.
Dylan, I'm going to let you go so I can get to my next one. I'm looking at some of these further down the page. They
Yeah.
all look like
Same.
they're going to end up with quadratics. In other words, that one's a quadratic. That one starts as a quartic, but I can take an x squared out of it, leaving a
Hmm.
quadratic.
Right.
This one starts with multiple variables, but I can take a y squared out, leaving a quadratic, an x. I don't
Okay.
see any problem here that doesn't end up with a quadratic. So what you just have to do is factor out the greatest common factor and
Hmm.
deal with the quadratic that's left.
Okay.
And I'll bet you all of them even factor. In other words, I bet you don't have to use the quadratic formula on any of these. I can
Yeah.
tell by the size of the numbers. If
Okay.
they wanted you to use the quadratic formula, they wouldn't be giving you big numbers like this.
Right.
Kind of
Okay.
that's kind of the giveaway. So
Yeah.
anyway, so this Wednesday, are we going to do 5 o'clock? I could switch at 8 o'clock as long as you do it now. I can't guarantee
Yeah.
that. I can't guarantee that that later time will be available by Wednesday.
Okay, yeah, let's just switch it to 8 o'clock. 'Cause I know I have practice that night.
Okay, that's
Yeah.
the best thing to do is to do that.
Okay.
And like I said, talk to your dad. I don't know why he would. He had
Think that, yeah.
Well, he had to know you were still doing baseball. I mean, I don't
He
get it.
had, yeah.
But anyway,
I don't,
talk. So does that mean next week I should put you at 8?
yeah. Let's do that. Next week's our last week that we have for practices. Um, and then,
I'm moving you to
yeah,
8 right now because it's open and I can do it.
yeah, let's just do that.
Ah, wow. Oh, God, it disappeared for a moment. Um, I don't have you. Oh, I have you here. I know what I did here. I'm going to put you at 8 on Wednesday
Okay.
because I wasn't quite sure what was going on, so I put you in combination with the other.
Okay.
All right.
Okay.
So you're at least for the rest of this week and next week, you're at 8.
Yeah.
All right. Dylan,
Cool.
have a good one. Talk to you later.
Sounds good. Thank you, Mr. Cowan.
Bye-bye.